All right, welcome to what I call Lecture Zero, material that is not related to the learning in engineering mechanics. Nonetheless, I find it important to share this knowledge with you or to make you aware that you should have this knowledge. Technically, it's assumed that when you enter this class, some of the knowledge that I will show you throughout this zero lectures, that you have that already, but my experience is that not everybody has that knowledge equally. So I want to guide you real quick through these pages to show you what is expected of you and what will be your backhand knowledge effectively. So right now I just want to welcome you, and the first part here really is informational. So I want to show you the general philosophy. I don't want to read this to you. This is something that I wrote so you can read this yourself. The same is true here for the general importance of engineering mechanics. I made this available to you. Of course, I could talk forever about these, but that's why I wrote them, and I don't want to bore you in this video with that. So just go ahead and work your way through that. Now, there is also, of course, the other part, which is, hey, why should I even take engineering mechanics? I believe it's not for me, but I will tell you that engineering mechanics is important for all engineers, and the reasons you can find here in this paragraph. This is only a part of why this is important, but let me tell you, there is a reason why your educational experience includes engineering mechanics, even if you don't believe it's part of your discipline. So educators had a reason in mind when they worked through that, and I wrote some down here for you. So please feel free to work your way through that. I think it's helpful to know this stuff. Also, there's a purpose to this lecture script. We covered a little bit of this in our 0A video, but here I wrote out how you can interact with the lecture script, and I invite you to work your way through that as well. And then I clarified for you here in written words how to use this lecture script. We have talked about this in a different video, in a previous video, 0A. But here I provided in case you prefer to read or have something documented at hand. So this may help you to actually work your way through the lecture script and helps you to clarify what we're trying to do by this actual lecture guide. All right, so that's the first part. Now it becomes a little bit more applicable for what you need to know. This was just informational. Let me move on to the next page. So the first thing that always worries students is the homework, but believe me, it seems a little bit tedious at the beginning if you read through all the rules here, but they are really designed to help you to succeed and to not doubt anything. So these rules apply across the board and throughout this class, and so once you master them, they will help you, I promise you. This is something where the students initially get kind of like a shock effect because it's the first time that they see these engineering rules, but it will help you to really be successful. And so here we cover everything you need to know about the homework. It's also covered in other places on the website, but this should help you to get clarification on anything you need to know about the homework concept at least. And then for the content, we will teach you that later. All right, that's the homework. Let's move on. So now we move into really relevant stuff for engineering mechanics, and these are some general engineering rules. And I'll be honest with you, those are not always applied in engineering education, but later on in your job, they apply. So I make an effort here to explain to you why they actually applied throughout this class. This is not something we're pulling out of thin air. This is important. This is something your bosses will expect from you sometimes later on. Sometimes it's a rule that helps us to streamline, and some things are just general understanding or general engineering knowledge that engineers apply to communicate effectively. So please be aware of those. And I laid them all out for you properly here, so please read through those. For example, the engineering paper, if you've never heard about this, you find information in this paragraph how to access that. And then we have readability, that is very important. Sometimes students come to this class, or sometimes students believe they can be engineers with whatever handwriting they want to have, but that is very far from the truth, because you as an engineer have to communicate. It's the most important thing you do when you leave the college. You may not believe this now, but later on you have to communicate. And often you have to communicate on paper. And so the most important thing is readability, and so that somebody else can understand what you calculated. It can be very dramatic if another person does not understand what you have done on paper. It can actually lead to fatalities. So please understand why this is an important rule in this class. We have the 4 significant figure rule. This is something that's laid out for you here on this paragraph. So please read your way through it. And I try to be explicit of how this works and why it's so important for engineers. All right, then similar things apply to the leading zero, if you will. So the leading zero is a very important thing if you do hand calculation, and in this class everything is done by hand, so this is important. This is different when you work on a computer screen, because that cannot be misinterpreted, but by handwriting, leading zeros, if you leave them out, they can hurt you if you overlook them, or they can actually also lead to fatalities. There's something called the scientific notation. This is something that engineers use to communicate more effectively. Again, you can read all about this here. Same is true for the prefixes, the SI prefixes, the mega, the kilo, the giga, and so on and so forth. So please be familiar with those. In fact, your very first homework will be about this. Then, why are units important and how do we deal with units? That's also laid out to you here. Next up is the gravitational acceleration and the constant that we use for that. We are engineers, we are not physicists, so let me be very clear about this, because often students like to use 9.81, and I have a long discussion with them that is precise and they need to get all the precision through. But first of all, think about the 4 significant figure rule from the previous page. And number 2, we are engineers. We don't use the 9.81 because we are trying to be conservative. So it's very important that you at this point buy into the idea that we're using 10 meter per second square for everything in this class. Never use 9.81, and it's very simple because it makes our life more safe. So please understand that. Last but not least, it's important that we always double underline our results and also provide an answer arrow. So for example, if I have a result of, let's say, G is equal to 10 meter per second square, then it's important that I A, double underline this, and B, provide an answer arrow. And the reason for that you can find in this paragraph here. So this is not something that I pulled out of thin air or I invented to bother you. This is standard engineering communication and is very important in the practical world. So please use this because it sets you up for success. While not every professor will ask you to do this, not even in engineering, you hopefully agree with me and some of my previous students who usually find out at the end of the semester that this is a powerful tool and that this can be used in all engineering classes or in all engineering applications. So many of my students come back to me and tell me, hey, this is something I use even if I don't have to now, because it makes my work more structured and it helps me to be more organized. So don't take this lightly. These rules here are all applicable throughout the class and for everything that we do here. So to get full credit, you have to always apply these rules, and the sooner you familiarize yourself with them, the better. So now let's take a look at our checkpoint page, and then we don't have a homework for the zero lecture because that's just not relevant here. But let's conclude this lecture with the checkpoints. So here you see our checkpoint page, and I would now ask you to go ahead and fill out what your takeaways are, what have you learned in this section, and then what is still a little bit muddy to you and how can you get clarification. This is a zero lecture, so I leave that up to you. I will, however, take you through our final checkpoints because we want to know what the goals here were of this very short, very brief video lecture. So first of all, of course, we may not believe it yet, but maybe it is true that the engineering concepts are really universal and that they are very helpful for any engineering discipline. So engineers need this no matter what your discipline is. And if you believe it, please check it off with me. If not, then good luck to you throughout the semester. I'm also aware now that the lecture content, of course, is individualized and separated so that we have single focus topics that we can build up on, and that will help us to maneuver the class effectively. However, please be aware, as you find in the text above, that these topics are actually interconnected. So although I break those down for you, engineers need to connect the knowledge or pull the information together. That's very important. And I encourage you to always keep an eye on that ball effectively. So do not get this out of sight that yes, we try to spoon feed you some information in education, but ultimately engineers really need to apply knowledge from all facets. You cannot think in terms of classes. You need to think as an engineer, holistic. But this is something later for your career. Right now, we obviously want to think about individual topics and we want to learn about them, but later on, you need to understand that all the knowledge needs to be pulled together. So don't lose sight of that. However, let's move on to the next box, which also tells us something about the homework. And we talked about this at other locations as well, but every lecture is accompanied by a homework assignment. So we know that. And you can master this homework by means of the knowledge provided in the lecture. So this is all knowledge that can be found in each individual lecture. And hopefully you believe me at this point. Later on, hopefully you will be convinced by applying that. Then you are aware at this point that there's such thing as a 4-digit ID. You find more information about this on the web in locations that are laid out for you. And these 4-digit IDs can be used to create your personal homework variables or your personal numbers, if you will. So that I can check off as well. And then last but not least, I know about all these rules, right? So the general engineering rules, which include the 4 significant figures, double underlining, brackets for the final units, and so on. And I will hopefully from now on always apply those for any engineering task. This is just good practice, and if you're convinced that this is good, please check it off with me. All right, so this concludes this current lecture, Lecture 0B, in which we covered a little bit the teaching philosophy and the philosophy behind engineering mechanics. Then we talked a little bit about the engineering rules and why they apply, and I encourage you to read all about this and how we need to maneuver the homework and all the calculations that we cover in this class. So that means we are now ready to move on to Lecture 0C, which I will see you for in another video. And there we will cover some of the basics that you need to bring from a geometry standpoint. So we will talk about trigonometry and some other basics that are technically expected from you at this point, but my experience is that not everybody comes with the same knowledge to the class, and therefore I create some of these 0 lectures so that you can be prepared, or at least now use the time to prepare yourself before we dive into engineering mechanics. So I will see you in the next lecture. Until then, stay safe.